It says standard deviation. Notice you have 5 steps. And what we're going to do is we're going to go through the 5 steps right now. But this is on your note guide, so you should be writing down nothing right now. You're not writing anything down. Okay? We got our 5 steps. And excuse me. Quick Rios. Yesterday we talked about measures of variation that look like this. The measures of variation from yesterday that we learned about and we actually posted a video about was the range. We posted a video on range. That gives the scientists of how spread out the data is. While the second way of measuring variation is called the standard deviation. It's on your note guide. And you have this nasty looking, scary looking formula that looks a lot scarier than it actually is. So what I want to do first is I want to talk about what each one of these variables means here. The n, the sigma in Greek, the x bar. These little x's with little numbers underneath, like an x sub 2, x sub 1. What the heck do all those mean? Once we know what they mean, this formula means it's very, very easy. You might even laugh at how easy it is. So the first thing we're going to do is, you're on your note guide. We're going to talk about what each one of these variables means. We're going to draw little arrows. So do it with me here. The first arrow, draw an arrow from the word standard deviation to that variable called sigma. It's like a little 0 with a little tail. It's a Greek letter like pi, or epsilon, or omega, or alpha. These are all Greek letters from the Greek alphabet. This is called sigma, and in mathematics, sigma always means standard deviation. Ms. McNair.
So we write down the standard deviation?
Right, so go to draw an arrow from the word standard deviation to,
like
to sigma. Yeah. So this is all on your note guide right now. The back side. I think I gave this to you. You too, Rios, you have this. You have this note guide.
No, just
Gotcha. Just get a piece of paper out then for notes. We're going to get into an example right now. We need a better one. All right. So sigma means standard deviation. What about this little lowercase n? I'm going to put an arrow there on the lowercase n. I'm going to put number of data values. Number of data values. All right. We know that X bar, we just did that for warm-up. What does X bar mean all the time? I'll be honest, please. What does X bar mean all the time?
Mean.
Gracias. The mean, the average. All right, so slowly but surely, this formula is not looking as crazy and ugly as it seems to be. And it's just the number of observations or data values. For warm-up, we had 5 because there's 5 movies. That's just the number of data values. X bar, we already know what that means the mean. Now look at these. Look at this. These x's with the numbers. These, like right here, x sub 1, x sub 2, x sub n. What the heck does that mean? Well, x sub 1 means first data value. First data value. X sub 2 means second data value. And so on. Look at, they got a little dot, dot, dot. That means till the end. This would be the last data value. Last. So X sub 1 means the first data value. X sub 2 means second data value. And then X sub n means last data value. So for warm-up, this would be the 5th movie, the 5th data value. Remember those 5 movies? So this is the number of observations, number of data values. We got the mean. This means standard deviation. And now what we're about to do is actually we're going to use this formula and follow these 5 steps in using it. So I'm going to start off with a very simple example, and you're going to follow me with your sheet of paper now, the blank sheet of paper, because this is not going to fit on your note guide. On the blank sheet of paper, we're going to use this formula. We're going to follow these 5 steps. Here we go. Questions so far? Let's do it.
Right, so-
You don't have to write the steps down because the steps are already there. All right, here's what our first example is going to be on. Our first example is going to be on texting. Here we go. So on your note guide, on your blank sheet of paper, go and write example 1.
You don't think I get my binder real quick? So I can have the notes.
Where is it? Where is it?
My friend is in his class.
We'll do it after the notes.
Alright.
Well,
Good, right? Okay. Yeah.
That means I have to catch up later and then.
So you can. Okay, I'll get it with you later. Yeah, I'll print it out because I already ran out of copies. All right. So example 1, we got texting. Let's imagine Garcia and Rios. You guys keep talking. I'm asking you to stop talking to the floor. Like, help me out. Appreciate it. Let's imagine I follow 5 students at Park West. Just follow them around for the day. And what I want to know is how many times they consult their phone. Sociologists are actually doing that currently. There's a lot of studies on the effects of screen time on the phone, on the mind and brain development. Because the smartphone has just come across our society within the past 10 years. And the ubiquity of it, that means the widespreadness of it, a lot of sociologists are actually studying, and the effects of it. It's still very, very recent and very, very new, and we're kind of like the guinea pigs, so to speak, in our society. And a lot of people are addicted to their smartphone. And let's just say I'm a scientist, I'm just going to study 5 Park West students, just for the sake of an example. And I follow around each student. And one student looks at their phone, let's say, 100 times in a day. Go right at 100. Second student looks at their phone 80 times in the day. That's a little bit of... Third student, 300 times. So this is a make-up example, just so I can get through the 5 steps. Let's go 4th student, 500 times. Okay? So I study 4 students. I follow them around. School, home, on the way home, on the way to school. I'm just observing them. Here's the 4 students. All I'm doing is how many times they look at their phone. Right, Mendoza? Yeah. Okay. Let's go to step 1. We're going to find how spread out is my data. Well, one way is a range. We did that yesterday. But the second way is what we call the standard deviation. Okay, here's the 5 steps. Step 1. It says find the mean. Let's do it. So on your note guide or on your paper, let's find the mean. So X bar, here we go, is, let's add these puppies up. 100 plus 80 plus 300 plus 500. There we go. 17?
Huh? What?
It's 988. 980? No. And I'm going to divide that by 4, right? Because there's only 4 observations, 4 data values. So, I got 980. Help me out, please. 980 divided by 4 data values. There we go. 980 divided by 4, I want to say, is 245. Rocket and rolling. Here's our average, our mean. Going to box that. That's step 1. Sure, sure. There's our step 1. Cool. Garcia, can you read step 2 for me?
Find the deviation of each data value.
Okay. There's a word deviation now. Okay, so deviation says find the deviation of each data value. That means Deviation means to stray away from something. So, for instance, if you go to prison, a lot of prisoners and criminals are referred to as deviant people, deviant citizens, because they deviate, they stray away from normal behavior. So the word deviation means, it has the idea of straying away. So the question is what Garcia just read is, how far does each student, I remember I followed 4 students. How many times I looked at their phone? I followed 4. How far does each student stray away from the average? How far away are they from the average? The average, we just found out, was 245. There's your average. How far does each one of these students here stray away from or deviate from? That's the word deviate, means to stray. How far did this person stray away from 245? How far did this person stray away from 245, and so on? What we're going to do now then is to figure that out, we're going to create a simple table. Watch this. So on your note paper, going to give me a 4-column table, like that. Take up a good amount of space. Right, Rand?
Yeah.
Let's name the first column X. Let's name the second column mean. X bar, which is mean. Third column, how far is each data value from the mean? How far did it deviate? How far did it stray? Well, to figure out how far they stray, you just subtract the 2 numbers. How far is one number from another? You just subtract the 2. That's obvious. So I'm going to take each data value and subtract the mean to figure out how far each one of those 4 students strayed away from 245. And then the last one, I'm going to put x minus x bar to the second power. Ignore this last column. We're going to come to that in step 3 right now. But right now, we got 4 columns. What we're going to do is we're going to figure out how far each student strayed away from the mean, or shall I say, deviated from. I got a pen as well.
I got one too.
Good. Okay. Sure. All right, we go. X data values. There's 4 of them. We got 100, 80, 300, and 500. Here we go. 100, 80, 300,
Yeah, no.
and 500.
Oh, yeah.
So go ahead and write down your 4 data values. 100, 80, 300, and 500. Cool. Now let me write down the mean. That's what X bar is, 245. We just did that together. 245, 245, 245, 245. Nice. Now, how far did each observation, each data value stray away? Right. Exactly. How far is 100 from 245? Well, that's what the third column's for. 100 minus 245, let me take that here. So, negative though, huh? Look at negative 145. I'm taking the data value, x, and I'm subtracting the average, the mean, to figure out how far away it was from the mean. 100 minus 245, negative 145. 80 minus 245, negative 165. Cool. 300 minus 245, I want to say is 55. Positive, notice. And 500 minus 245. Nice. There's step 2. We just did what Garcia read a little while ago. We figured out the deviation of each observation, each data value from the mean. Cool. Franco, read step 3 for me now. Square each deviation. The deviations are right here. Negative 145, negative 165. These are all deviations. He said to square them. That's this one right here. Look at squared. We figured out how far each observation was from the mean. Now we're going to square these puppies. You're going to need your calculator for this, but I'll do it for us. Here we go. 145. Negative 145 times negative 145. Watch this. Right. I'm going to get, watch this, 21,025. I'll do it for us. Just write it down. cool. Negative 165 times negative 165. 27,225. So right now we're on step 3 of the 5 steps. Okay, 55 times 55. 3,025. So far, so good. $255 times 255. 65,025. All right, there's step 3. We just squared the deviations. So far, so good. All it is can you follow directions? Nothing high-level thinking here. All right, here we go. Step 4, McNair. What does step 4 say? Sorry about that.
Find the mean of the squared
Deviations.
deviations. This is called the
variance. So it says, find the mean of the squared deviation. So here's our squared deviation right here. Find the mean of them. Find the mean of those. So I have to add them up, divide by 4. So let's go and add these puppies up. Here we go, 21,025 plus 27,225 plus 3,025 plus 65,025. So I get, watch this, I get a grand total of 116,300. But it says she just read take the mean of all these. So I added them up. Now I'm going to divide by how many? 4. So there's 4 data values. So right now I'm on step 4. It says take the mean of the squared. Look at these are the squared deviations. So I'm adding them up, dividing by 4. I get a whopping total of 29. Watch this now. 29,075. Go ahead and box this number, put an arrow, and go and write the word variance. This is called the variance. We're on our last step now. We're on our last step. First, write down the word variance for me. All right. So, Dollars, read step 5 for me.
Take the square root of the variance.
Take the square root of the variance. There's our variance. Take the square root of it, we're done. There's your standard deviation. Watch. So on your notes, go to write sigma, remember that's what the standard deviation means? Sigma equals the square root of 29,075. I'm going to go and punch that in a calculator, just run the nearest whole number. Watch me do it. So let's see, the square root of 29, was it 045? Was it what the number? 0, thank you. There it is. I got 170.5. I'm going to run the nearest whole number for now. Whole number. So I'm looking at the 0, which is in the whole number's place. That's 5 or bigger, so it's approximately 171. Let's come back over here. So the standard deviation then is approximately 171. Write that down. Again, this little variable sigma comes from the Greek alphabet. Sigma always means standard deviation. Standard deviation is approximately 171. So what the heck does that mean? So we did all this gymnastics, all this calculation, we've got this number 171. What does it mean? Here we go. Here's what it means. With an arrow. We're going to write each student on average is 171 away from normal. Each student on average is 171 away from normal. And when I say normal, I mean the mean. On average, the 4 students I studied, the 4 of them I studied, on average, if you take each one, they're about 171 away from the mean, the average. The average, when I say normal, I mean the average. Remember, the average was 245, right here. Each student was about 171 away from the average. So this number gives a scientist an idea of how spread out their data is. The smaller that number, the more tighter and condensed the data is. The bigger this number, the more spread out the data is. And that's important for scientists in whatever they're studying. This was a silly example of students texting. But that's what standard deviation means. It's how far was a typical person away from the normal. That's it. No biggie, right?
No, it's just me.
Right. What I'm going to do now, I'm going to go over a second example, but I'm going to go fast now, and we're done. I'm going to go fast. I'm going to go through the 5 steps fast. Okay, watch. So go to write example 2.
Is there like a shorter way of doing this?
Yes. But I can't show you the shorter way until I educate you on the longer way, because the longer way, gentlemen, I'm talking please, the longer way involves the details of what's inside the formula. But there is a shorter way that takes like 5 seconds.
After this semester.
Yes. But I got to show you the long way. That's part of education. Here we go. Example 2. I'm taking another 4 students, and here's the spread now. I watched them the whole day. The first student looks at their phone 5 times. Second student looks at their phone 800 times. Third student looks at their phone 100 times. And the fourth student looks at their phone 900 times. So far, so good. I'm going to go fast now. Step 1, let's find the X bar. Here we go. The mean. So we got 1,808, so see, 1,805, divided by 4. So add them all up, divide by 4, 1,805, divided by 4, rock and rolling. I get 451.25. I'm just going to round the nearest whole number for our sakes. Okay? So the mean is approximately 451. Look at it. This is not 5 or bigger, so that stays at 1. So 451. Cool. There's our mean. Step 2, I'm going fast now. 4 columns. X bar. How far is each X from the X bar? And then I'm going to square those puppies at the end. Okay. X's mean our data values. So watch this. 5, 800, 100, and 900. That's easy. The mean, we just figured out, was 451. Again, I'm going to put 451 each time. Because I want to figure out now, I'm on step 2. How far did each student stray away from the normal? Remember, average means normal? How far did each student stray away from the normal? Well, let's subtract those puppies. 5 minus 451. I get negative 446. Cool. 800 minus 451. 349. Cool. 100 minus 451.
Negative 351.
Gracias. No big deal. 900 minus 451. 449.
Yeah.
I'm so bad at mental math. Now I'm going to square these puppies. Let me get some nasty big numbers in this. Okay. Watch. Here's step 3. Here's our deviations. This is how far the first student strayed away from the normal. This is the second student straying away from the normal. Remember, it's straying away. Normal is average. How far did each one stray away from average? Here they are. Now I'm going to square these puppies. 446 times 446. 198, 916. 349 times 349. 121, 801. 351 times 351. 123, 201. And then 449 times itself. I got 201, 601. Rocking and rolling. Step 4, going fast. I'm going to take the average of these now. Average. Just say them out loud to me because I'm going to use this calculator. It's a lot better. I can just type them all in at one time. So the first one is what? Can you give me the first value? 198. 198, 916? That one, right? 198, 916, okay. Plus, what's the next value? 801, thank you. Plus? 201. Gracias, appreciate that. Extra stand for that. Okay, there they are. I like this calculator. It's Desmos. If you go to Desmos Scientific, it's really nice. You put them all in at one time. Now, I'm going to press equal. Okay? I'm going to divide that by 4. Right, so divide that. So what I got to do is I got to take the answer. Check this out. I'm going to take the answer, that's that, divided by 4. And I get 161,379. 161,379.75. I'll round to the nearest whole number, so it's going to be 161,380. 161,380. $161,380. Okay, so this is my variance. So the last step says square root the variance. That's your sigma. That's your standard deviation when you take the square root of that puppy. The cool thing is my calculator already has it on the screen. So let me go back to my calculator. I have the answer on my screen, so let me take the answer, let me take the square root, and then the answer, the previous answer, which was that, the 161,379. Okay, there it is. 401.7. The nearest whole number would be what?
402.
Thank you, 402. So here we go. Our standard deviation then, watch. Our standard deviation is approximately 402. Compare that standard deviation to example 1. Example 1 was 171. Example 2 was 402. Why? Ekis on why? How come? So my question is this. Why is the second example a lot bigger than the first example? What's the point? And you went like this. What are you trying to say? Right, look at the data. These were a lot more separate than the first set of students I studied. The first set of students I studied were a lot closer together. The second group of students were a lot farther apart. So the smallest was 5, the biggest was 900. So that's an elasticity, big range. And so you're going to have a bigger standard deviation number, 402. That's why. So the bigger the number, the more spread out your data is. The smaller number, the more compact and condensed your data is. We're done for the day. I'm giving you about 20 minutes to work on your assignments. Take about a 2-minute brain break if you need to. Check your phone, whatever you want to do. Grab your Chromebooks. I'm giving you the rest of the time to work on assignments. Let's get big busy. You may. Sure.